In the preceding movie, we created some code so that the capsule object here would continually rotate to face this cube. And very often that will be just what you need, but in some cases that is not enough. When you are creating mechanical gun turrets, for example, these will rotate at a particular speed, and often the object they are trying to look at is too fast for them. When the object moves too fast, the mechanical unit will still be rotating and trying to catch up to target the object. So very often the object should rotate continuously over a period of time. It may not be able to rotate as fast as the target, in which case it requires a certain period of catch-up time. So I want to create that now by using quaternions. I'm going to go back to MonoDevelop here, and we can see that the code we had before. What was happening previously is the quaternion.lookRotation function was calculating our final orientation, the orientation we should be at when we are looking at the target, and it was assigning that directly to the rotation property. This time we don't want to do that. We're going to create an intermediary quaternion structure and have this rotation property catch up to that destination. So to get started at doing that, I'm going to create a local variable here called quaternion. And if I can spell right today, so quaternion, and I'm going to call this destrot, and it's going to equal the quaternion that we create from lookAtRotation. So lookAtRotation is going to calculate our destination or our final rotation and assign that temporarily to the variable destrot. And our transform.rotation field is going to be constantly trying to catch up to that destination at a particular rotation speed. Now we have a function built into Unity that can achieve this kind of behavior for us, and it's part of the quaternion class. So transform rotation is going to equal quaternion, and we have several different functions that we can use. The one that I'm particularly interested in here is the rotation towards. So rotate towards. If I select that, you can see that this function requires 3 parameters. The first is the quaternion from. This tells us the current rotation, the rotation where we are right now. The second parameter, quaternion to, tells us the rotation that we should actually reach, which would be the destination rotation. And the third parameter refers to the speed, the turn speed in terms of angles per second. This is the amount that we can actually rotate from the source quaternion to the destination over time. So I want to choose rotate towards. Now the first parameter is our current rotation, which is always going to be encoded in this transform.rotation. That tells us through a quaternion where we are in terms of orientation right now. The destination will be the destrot that we have calculated here using quaternion.lookRotation. And the third parameter will be our rotation speed, which should be rot speed multiplied by time.delta_time. So there we have a complete code to turn an object to face its destination over time. Let's take a look at this code up and running inside Unity. So I'm going to minimize MonoDevelop and go back to Unity here, now having saved the code. And I'm going to press play on the toolbar. And when I do that and I take the destination, you can see that we're turning to rotate it. It's actually doing that, but maybe we want to slow down the turn speed just a little bit so we can see it a bit better. That's quite easy. All I have to do is select the capsule here, and in the object inspector for the rot speed field, I'm just going to slow that down to, I don't know, 30, and then press play on the toolbar. And now when I move the destination, you can see that now this is gradually catching up to our destination. So I'm going to go over here. And you can see it's catching up, and it takes a certain amount of time to do that. So here we've created the ability to create a target object that can turn to rotate an object, but it can do so by rotating at a particular speed slowly over time, and this can greatly enhance the realism of your levels.